So good afternoon, everyone. Today we'll be presenting to you our progress throughout the semester, working on our project, Augmented Reality-based Social Network. First, let me introduce our team. We are Ahmed A Marzouk, Ahmed Sharaf, Alaa M Mohamed, and myself, Engy R Hassan, and we're working under the supervision of Dr. Sherif Aly. So I'd like to start by giving you a quick introduction to the contents we'll be talking about. First, we'll be defining our idea and telling you our requirements. Then we'll tell you a little bit about the AR technology research we conducted and the decision we took. After that, we'll be giving you a quick demo and then elaborating on the main features we have. After that, we'll be talking about two main technology points, which are depth API and location. Then we'll be talking about our architecture, back-end technologies, and the last thing will be our business model. So let's start by defining the idea by telling you actually like what are we aiming for. So the first point is an interactive augmented reality experience. So what do we mean by this? So when we looked at the current augmented reality applications and where they're headed to, we found that they're headed towards the commercial direction, where like you actually get some static objects and you just post them, or you just like try them. You don't get to post your real content. You don't get to interact. For example, think about the IKEA application that allows you to place the furniture and try it. All of these applications. So we believe that augmented reality can have much more power in providing a new virtual world or a new virtual community. It's a really interesting technology that will allow us to do this. Additionally, we want to have a creative space that gives users the space to express their ideas in various ways. For example, imagine a user that wants to place a text post, but he wants to place it in the pyramid, in a place like special to him. Or, for example, imagine a user that wants to express something through a moving 3D object, or we want to allow users to post whatever they want, wherever they want, and in whatever format they want. And we believe augmented reality is the way to go in this part. And finally, we want an immersive experience within the real world. We don't want the posts to be within a virtual feed. We actually want them to be immersive within the real world. So, and the end result that has all these aims is a social media platform immersive within the real world using augmented reality. So let me start talking a little bit about our main features. So first we have sign up and login, of course, because users will have accounts. And also we have the idea of adding friends and importing friends from other social media platforms because we want users to be able to also interact with people they already know or with like their friends. Also, we have posts. We have posting 2D objects and 3D objects. For 2D objects, for example, we have posts and images. Also, we have the idea of layers. What do we mean by layers? It's a space where a user designs, like where a user creates for him and like some people he chooses to post on and see posts on. Of course, we have a public layer where all people within the same place interact, but also a user can create a layer for his friends and for himself to post whatever they want. We also have a switching between layers, of course, for users to see the content from different layers. We have interactions with posts such as upvotes, such as comments. And we have interactive content, like, for example, polls. And finally, for the 3D objects, we'd like to have also moving objects, not only static ones, moving and animating ones. So this is the set of requirements we decided that we want to have in our application. And after that, I'd like to talk to you about our technology research, like what did we decide we want to use. So first, we started to explore the commercial AR technology platforms, or SDKs. The main ones we tried were Codin, Wikitude, and Onrix. And by trying the three of them and other ones, we actually found that our main problem with all of them is that they do not give us the flexibility to design our application in the way we want. They are more headed in the direction of making it easy, for example, for a business to have a side AR application, but they don't give us the flexibility and the technical performance we want. So we started exploring the open source SDKs, such as AR Core, which is created by Google for Android devices, and ARKit created by Apple for iOS devices. And our final decision was actually something based on those two. Let me elaborate on this a bit. So first, we decided to have a cross-platform application using React Native, which is well supported, and which is well supported and well known in this area. Also, we decided to use VReact. What's VReact? This is an SDK that uses AR Core for Android devices and ARKit for iOS devices. And let me tell you why this is the most suitable idea for us. Firstly, the idea that it uses AR Core and ARKit for iOS and Android gives us a better performance than an SDK that uses like a common SDK that uses the same thing for all devices. Also, it's an open source, so it's free and it has a highly active community. Also, it provides more abstraction for us in the development. We will not be reinventing the wheel and writing all the functionality from scratch. We will be developing from a little bit higher level. And finally, it allows us to have like faster development based on this abstraction, and hopefully like faster time to the market. Now we'd like to give you a quick demo for our application. 1 second. Ahmed Marzouk will be playing the demo now for you.
So that was a quick demo to show like some of the features that we allow, and we will continue with the other features with Alaa. Engy, can you please share?
In case Alaa, in case you are speaking, you are muted apparently.
Oh, I'm so sorry. I didn't notice that. Okay, so basically, I'll go over the features that we have. Basically, as showed in the demo, we can post different kinds of content. The first kind is post is a regular post. It's basically a text-based, but we can add some like some decorations to it. So we aim to provide some containers for the text-based posts. Next. Interactive content, we plan to have multiple types of interactive content, but the very basic type is the poll, which basically allows a user to ask a question or and give different possible answers, and the users can interact and give their opinion. There are also multiple interactive objects that we plan to do. Most of them are should be integrated with the real world environment. So like 3D objects that can like interact or show some animation when the user clicks on them and something like that. Next. The images, we allow the user to add images directly from the gallery or through his camera. And the last thing is the 3D object, which is the most important part of our application because we want to create an immersive AR experience. So we support different 3D objects. Some of them are static, some of them are dynamic. And basically, we should create an API that fetches different objects that is scalable and updates and is updated on a daily basis for the users to choose from or call from external APIs to pull 3D objects. Next. For the content placement, we try to make the content placement as easy as possible and as convenient as possible. So, for example, if we're trying to place a 3D object, we don't want the user to go through placing the object on the surface to be like integrated within the environment. We try to make that as easy as possible. So we put some logic to snap to the nearest surface. AR Core provides some functionality to detect the objects in the environment. So we use that to detect the nearest surface, and based on that, we place the object in the real world. Also, After placing the object, the user has the option to position or rotate the object by simple dragging or touch gestures on his phone. So we want to make the content interactive, so we provide some interactive features to the post. For example, the user, in order to interact with the post, the user does not have to click on a post. He just hovers over it. When the camera is pointing at the object, the application automatically detects that he's looking at the object and provides the user with the information and the UI related to that post. For example, the profile image and caption and so on, and the UI components for interaction, like the like button, the upvote button, and the poll interaction where the user can choose an answer. And the last thing is the upvotes and likes and comments. So next. As we said, the user has the option to choose between different layers in an easy way in the UI. So next. So now I'll talk about Depth API. Basically, that's an important technology that we're using. Basically, let's know first what is Depth API. It's a technology supported by Google. It's developed by Google, and it's a part of the newer versions of AR Core. It basically tries to estimate the depth information from the scene by understanding the scene and seeing, for example, detecting that there is an object in this location at the distance X from the user. At this point, we can use that information to provide some extra functionality to the AR interactivity in the scene. For example, if we know how far an object is, we can know whether it's in front of the virtual object that we're placing or not. If it's in front of the object, we need to occlude the virtual object that we're creating. So, for example, if you look at the cat example at the bottom, you can see that the chair is in front of the cat. So we need to occlude a part of the cat in order to appear that it's behind the real object. So that's basically what Depth API does. It's basically a new technology that's developed in the last June. So it's only like a few months old. So it's a really good opportunity to invest time in that. So this is a cool feature, but it's actually essentially to our application. So we see it as an essential feature because of our vision. We want to create an application that's completely blended with the real world and provides an immersive AR experience. In addition to that, we're trying to create an application that can have multiple, maybe tens of objects in the same environment. So we want to make sure that these multiple objects look good in the environment. Next. So I want to talk a little bit about the structure of our application, the dependencies in our application. So our application basically is using Vero React, which is using Vero Core. So Vero Core is something created by the same company, but it's basically a wrapper around AR Core that provides some higher level functionality. So in order to support, well, the problem is the latest version of Vero Core does not contain the latest version of AR Core. So the latest version does not support Depth API. So we need to fix that. And in order to do that, we need to go all the way up through the hierarchy and do some modifications in Vero Core in order to support the AR Core, and then do some modifications in Vero React in order to support the new created Vero Core. So we need to make changes in the two middle layers. So that's basically, that can be divided into 4 main steps that we took so far. The first step is building our application from the manually built Vero React and Vero Core projects. So luckily for us, Vero Core and Vero React are open source, so we can edit them directly and support Depth API or support a newer version of AR Core, which allows us to use Depth API. So that's what we did. We actually built Vero Core and Vero React from scratch and made sure that everything is working properly with our application. Then the next step was to understand the structure and exposing some functionality from Vero Core to our application, because the structure is a bit complex, because Vero Core is basically built in Java and some native modules in C++, but Vero React is using JavaScript. So there are some like dependencies and different languages interacting with each other. So there are some complications. So we needed to understand the structure first. and then expose some very basic non-related, some very basic functionality that's not related to depth API in order to make sure that we can expose some functionality directly from VeroCore. Next. The next step was to update AR Core version used by VeroCore. So VeroCore is using an older version of AR Core, and we need to upgrade that in order to be able to use Depth API. So we downloaded the new AR Core version and integrated it with VeroCore and made sure that we can build the VeroCore project and then use it in the VeroActive project and then finally use it in our application. The last step and the most important one actually is exposing some depth-related functionality, which is our goal from the very beginning. But this is a bit complex because VeroCore and VeroAct currently does not support any depth-related functionality, and it's a bit hardware-related or hardware-dependent, so this might introduce some complexity. So that's still work in progress. Why not native development? You might be thinking, because native development will allow us to use Depth API directly, so we could just use it. Well, yeah, we can use it, but that actually would make it easier to integrate Depth API, but on the long run will add so much complications, especially that VeroCore provides some very good functionality that's especially important to our application. It basically provides some higher level functionality than the very basic AR Core functionality. So we compared the two options, and it was we decided that the better option is to add some overhead at the very beginning in integrating Depth API, but then in integrating Depth API in VeroCore and then using and that on the long run will save much time, would be much effective.
Okay, so how do we actually locate objects and save that information in our database? So first, let's consider the case that we are trying to store some data in our network. So we'll first consider the geographical position of the device of the user that is trying to post something to our network, and we assume that the user has a GPS high accuracy mode enabled, as this mode actually uses multiple metrics to come up with a highly accurate positioning, as it actually uses the Wi-Fi connections, the cellular data, and Bluetooth connections to better estimate the location. We also combine that with the relative location of the AR object, because in our AR space, each object has like XYZ coordinates relative to the location of the camera of the user. So we add these two information together, and we come up with the geographical position of the object. And we also store the Z coordinates, as we need that in order to reverse this process, in order to render fetched data from our service. So in the next slide, please. So now let's assume we have some data in our service. So to fetch some data, basically we'll consider the GPS location of the user, and we will fetch all the nearby objects given the geographical position of the objects that we have stored previously. And we will reverse the process that we have done in the previous slide and come up with the relative positions of each object relative to the camera of the user that is currently trying to fetch data. Okay. However, this feature, although it works perfectly outdoors, it has around 1 meter of error indoors. And we think that because of the XYZ coordinates is like an estimate. However, the Depth API that Alaa discussed will give us an accurate estimate of the location of each object in our AR environment. And we also are testing with the approach that we have suggested in our initial proposal. That approach basically is when a user tries to save some data in our service, we will get a photo of the environment, and we can color map this photo in order to protect the privacy of the user. Basically, group each similar colors in a rectangle of the average color. This photo, we can use it later, given the position of a device that is trying to fetch some data from the service. We can use the photo of the environment that he is facing together with the GPS data, and compare this data with the ones that we have in our database, and basically tries to find similarities between the environments given the location of GPS locations, and hopefully also translate that to XYZ coordinates in the AR space. Okay, so can you please? Okay, so now with the server architecture, as Ahmed Sharaf will discuss why we have decided to go with the microservices approach. Basically, like to briefly talk about it, we need like something very highly available and also easy to scale. So we have like thought about like a very like easy to scale model that can like allow each user to each kind of like load on each service to be like easily scaled and easily load balanced. And we will briefly like talk about some of the end-to-end communications that you have. So for example, the next slide. So to add a post to the service, we basically thought about a post integration service that will manage the actual content of the post and also manage the asset through another service, which we call the asset service, which basically like talk to multiple databases, maybe one for the images, one for data for the 3D objects, and so on. And we also decided that we need like a Bob sub service, which will actually like notify other services that needs to do like some analytics, maybe the like cache some data for future retrieval, because we want to like ensure like faster retrieval for users, especially that we expect since we are like a social network platform, we expect that the load will be like very high like in the near future if you go like live. So and the next slide, please. So to get a post, as I discussed, we have like 2 layers. So basically, the user will talk with the timeline service, and depending on the layer that he is currently in, he will talk to one of the 2 services that we have, like personalized service that will fetch like personalized data based on the user's interest, and maybe based on the friends posting and so on, and previous interactions. And other one is the public service, which is actually like the same basically experience for every user given a certain location. And all these services actually talk to a cache service first, because as I said, we need to ensure like fast retrieval of the data. Next, please. The other like basic functionalities, maybe such as like adding friends, you can actually like talk directly to the graph service. And the next slide. If you wanna like do any user profiling or changing any user data, you can basically talk to the user service. And now with Ahmed Sharaf, he's gonna talk about the specific technologies that we plan to use for our backend.
Okay, so as Ahmed Marzouk just explained, we are actually already on microservices backend technologies. Like going with the front end, we were going in backend technology as a backend parallel with that. Next. So for choosing backend structure, actually for our service, we were choosing between the 3 known structures, which is the monolithic, microservice, and serverless. But we actually excluded monolithic architecture from the options because like it depends on adding every services in one server. That's actually it can be good sometimes, but in our application it will not work quite well, because putting everything in one server means that like everything goes if everything goes wrong, the whole server will go down and go up with all its services at the same time, which is not actually very efficient. And also creating replica for that to make the fault tolerance better. We need to replicate every single service because all of them is in one server, which is actually not very cost effective nor efficient. And also in our application, because we have rapid development and we will be introducing new services soon. So actually integrating new services in that server structure is not easy, because you need to like every server, like all services are tightly coupled with each other. So you need to integrate them to reintegrate things and tie them up whenever you add new thing. So we left out with the two options, microservices and serverless, and actually we decided to make a hybrid structure between both of them, and I'll explain why. But first, the microservices is basically like taking that monolithic architecture and dividing it into very small pieces, calling every one of them a microservice, and then making a communication, making these services communicate with each other, and that we will have actually loosely coupled services that can be easily extended by adding new services, and you can add replicas for a specific service for more reliable fault-tolerant solutions. And the serverless architecture is basically the same thing, but with microservices. So every microservice can be actually divided into more smaller parts, which is functions or lambda functions. But we actually cannot, although this is like seems to be the least loosely coupled solution, but it's not reliable enough when it comes to production environments. So we make the hybrid model between them. Next. For the serverless part will be actually for the long-running tasks such as sending emails or heavy workloads or workflows. But any other service in our architecture would be actually based on the microservices. For example, the business logic, databases, load balancers, and Kubernetes, all that. Next. So as I said, we will be implementing the microservices architecture mainly. So we need to glue these services up with each other. So we have actually two options for that. First one is REST API, and second one is message queue or MQs. But we will go with the REST APIs because it's asynchronous, since it follows the HTTP request response communication protocol. So so that guarantees things to go synchronous. Despite unlike the message queue pattern, which is every service actually pushes a specific task in the task queue of other service, and services actually run their jobs at the queues asynchronous to each other. But we need the synchronous part because it's a customer, like it's user-facing app. So we basically need whenever the user posts a specific content, we need them to get the feedback right after that. Next. So after we settle down on the microservices and gluing them with each other, so we need actually to make that work. So for the production environment, we chose Kubernetes for our container orchestration since it is the best for that job. We will also be hosting that in AWS services. So basically, Kubernetes will actually handle the clustering ES2 instances in AWS. And also will handle the proxy servers and the replicas, fault tolerance, all that. Like beside EC2 instances that we will use as computing units for our backend architecture, we will also use some other AWS services such as RDS for our databases. S3 buckets for storing mainly images and the 3D objects user content, and the text content will actually be part of or be stored in RDS. We'll also rely on SNS for real-time notification and any event-driven computation required in our application. Next. So for us in the development environment, we need to have a very similar environment to the production, but of course we cannot use AWS like the cloud itself for our development environment, because that will be very complicated to replicate in our ends, and also will add some cost complications. So for us to make a very similar development environment, we use the Kubernetes as well, but this time runs using Minikube, which is a tool that allow running Kubernetes locally without needing to host it in any cloud computing or any cloud provider. And to simulate the AWS services, we use for that local stack, which is a fully functional AWS cloud stack simulation that actually provide almost every service that AWS can provide, but locally. So we'll rely on that on the development environment. So like that, we will have actually our development environment, staging environment, and the production environment all having very similar structure. So pushing work from a stage to the other will be very flexible and seamless. Next. So now with the business model, actually the very specific target audience that we are targeting is the people interested in social media in general, because at the end of the day, this is a social media application. But according to some surveys that we did, we found that like younger people will be more interested in our service. Maybe because it's a cutting edge technology and learning curve. We're still not sure about that, but we are sure that our target audience will include the most part of it will be younger age people. And of course, they will need to have a high-end smartphones because we are introducing cutting-edge technologies, and that will actually need to be supported from smartphones. So that will be, of course, needed. About the value proposition, we're actually introducing a promising technology in a very wide domain, such as the social network domain. So we have an edge on that, especially that the market has. Like there's no big competitors in that market yet. Like it's a brand new technologies, especially when it's used in the social network. For us to generate or for the demand generation strategy, we will be marketing our application and its usages in mostly every life aspect, such as health, education, entertainment, advertisement, and many more. Especially that our application can actually offer endless business potential in all of those aspects. Regarding the innovation, as I said, like because this is a relatively new technology, so there's always a space for innovation and introducing new features based on that framework. Next. For revenues, we are partnershiping with businesses. Also, we are offering premium features with paid plans. And of course, for the advertisement part, the advertisement in our application will be augmented. So we'll actually provide augmented advertisement model for revenues. The cost will be being technical services cost, fixed plus variable costs, which will be nearly represented by the invoices from AWS services. And of course, marketing budget at the very beginning for us to kickstart. And now moving to Milestones timeline.
Okay, so at the end, we just want to follow up on the milestone that we provided at the beginning. So the first two were actually done by the initial proposal presentation. Then by the first half of October, we worked on identifying technical requirements, then experimenting with technology, the initial experimentation. After that, we developed an initial prototype for the application or a proof of concept. Then we did some research based on the technical problems that we discovered. In the same time, we were working on a more refined prototype. Finally, based on what we reached, we finalized the application features and reached what we will do in our next milestone, which is developing a final design for the application or a more mature version of the application based on the design, based on the features we have now, then testing. So that's basically it. Thank you so much for attending. And again, sorry for the technical issue at the beginning, and we started a few minutes late. So yeah, that was basically it. Now we'd like to hear your questions or feedback.